Thanks, Sebastian, and welcome everybody. Welcome to this keynote about Angular, Vue, React, and so on, and also about combining those technologies. So let me introduce myself. I am Manfred. I'm a trainer and consultant for Angular, and I'm helping companies on a regular basis with workshops and with consultancy. I'm also part of the Google Developer Expert team. I want to start this keynote with a picture. Who remembers this machine? Yeah, some of you. This is a good old C64, the hero of my childhood, and it was released in 1982. This shows that I'm really getting old those days. And it had about 1 megahertz, which isn't much compared to nowadays computers. It had 64 kilobyte of memory, and when you had a floppy disk, you could save about 170 kilobytes. And in addition to that, it was also possible, no one would believe it today, to store some data on audio tapes. When you didn't afford a floppy disk or a floppy, then you could use those audio tapes. There was also a 2-core version of this machine, and it looked like this here. So when you needed 2 cores, then you had to buy 2 instances of it. And some developer did it. For instance, they used one for programming and the other one for testing and debugging purposes. And of course, when you think back to those times, you see clearly that the biggest challenge back then was resources. You really thought about using an integer or about using a tiny int or a small int or something like this, because resources have been limited. Nowadays, we have plenty of resources, especially in transactional systems. Resources are not a big issue besides of big data. And that's why we have to fight with other challenges, for instance, with complexity. Business software is growing big nowadays, and business software demands that a lot of developers are on this project. And so we have to tackle this complexity somehow. In addition to that, modern business systems are created by several teams. There is not just one team, there are several teams, and we need some coordination between those teams. That's another challenge. A third challenge is long-time maintainability. Big software systems, especially in the industry and business environment, have to be maintained and extended for 10 or 20 years. And then there is also this issue with milk products. You know, there are milk products out there lasting longer than some JavaScript framework, which is really an issue. And in this keynote, I want to give you two ideas how to tackle those issues. The first idea is about web components. The second idea is about micro apps, and I will also show you how you can combine those ideas to create a better solution architecture. I have also prepared a simple demonstration that shows how to do this. But first things first, let's get started with web components. As you might know, web components are about framework-independent components. That means you can write a web component with one framework and use it with other frameworks. So somehow, web components hold up to the promise of Java, you know, write once and use anywhere. There is another nice side effect when it comes to web components. They can really easily be dynamically loaded. Dynamic loading, lazy loading of components have never been that easy as with web components. Just load your bundle on demand and you have a plenty of new HTML elements in your system. To be honest, there is not one big standard for web components. Web components is just an umbrella term, and behind this umbrella term you will find several standards. And I have here the icons of all those standards. Let's begin with the first one. It's about templates. Templates are not a big deal. I mean, we all know templates. Templates are around for several years, and everyone who is using React or Angular or Vue is used to templates. It's just a bunch of HTML tags that are rendered on demand. Another standard is about HTML imports. The idea here is to import another HTML file into your HTML file, into your single page application, for instance. And so you could have a mean to import other web components into your application. The most important standard here is the custom element standard. It allows you to create own HTML elements that behave like the traditional ones, that behave like an table element, that behave like an image element, that behave like a div. You can also use those custom elements with vanilla.js, with some DOM magic, document.create element, and so on, to get in touch with them. And there is Shadow DOM. I really have to say the German translation because it sounds that mighty. It would be Schattendom. I really like this. It really sounds mighty. And this Shadow DOM is really powerful because it allows you to isolate your web component in terms of layout. That means the layout of your web component, the CSS files of your web component, doesn't mess with the rest of your page. The layout of your web component doesn't influence the other layouts of other components, which is quite important. I think you all know this situation where you have two CSS files, both of them work perfectly individually, and when you use them together within an HTML page, hell breaks loose. They are influencing each other. So we can immediately forget about HTML imports. This is something the browser vendors will not implement. They said, hey, we don't need another import system. We already have an importing system, namely the importing system of ECMAScript. Think about ECMAScript import commands, and so we will use also those ECMAScript import commands for web components. But the rest of them is still there, and the rest of them is implemented nowadays in all important browsers, in almost all important browsers. And the best message here is, even though you have to support a browser that does not support web components, you can almost polyfill everything. You can even polyfill everything down to IE11. And of course, when it comes to polyfilling, this is never perfect. Not each and every aspect can be polyfilled, but most of them is possible. And when you know your limitations and when you start testing with IE11 early, then you should be on the safe side. So this isn't a big issue. When you look at the API of custom elements, you see it is really drop-dead simple. You just need to extend the HTML element class using ECMAScript 6 or TypeScript, and then you can attach a new shadow DOM. Just call attach shadow, and this gives you a shadow root, which is an isolated part of the DOM, an isolated part of the DOM that cannot influence other parts of the DOM in terms of layout, and then you can deal around with this DOM. You can insert script tags, you can insert HTML tags, and so on and so forth. As you see here, it's really, really simple. Of course, this doesn't replace a traditional framework because web components and custom elements don't give you an answer for change detection or data binding. Here you are on your own when it comes to those topics, and that's why frameworks will still be vital. In addition to those methods, you have further methods, callback methods that are called by the browser so that the browser can talk with your web component. And when you have written everything, you can easily register your web component with the browser. Just call custom elements define. Custom elements define gets a tag name and it gets your custom element. And after this, you can just import the bundle with this code, and then you have new HTML tags that exactly behave like the HTML tags that are built into the browser. And that means those HTML tags work with each and every framework. You can even do data binding to them using Java, vue.js, and other frameworks. So as you have seen, it is quite simple, but we can do a bit better. When it comes to all those popular frameworks, there are more easy ways to wrap an existing component as a web component. For instance, when we think about Angular, we have this Angular Elements thing. A nice innovative library within the Angular framework. It landed with Angular 6 this May, and it allows you quite easily to wrap an existing Angular component as a web component. The Vue people have a similar solution. When you are using Vue together with Vue CLI, you just need to append a switch when calling the Vue CLI, and then all your components are compiled out as web components. When it comes to React, it isn't that easy. There is not an official solution for web components in React, but as you have seen, the API for custom elements is really simple, and we all can imagine that it is simple to wrap your React component as an web component by hand. Just enter your bootstrap logic into the code I've shown you before. And also, there are some community solutions for this. So as you have seen here, using web components is quite a straightforward way to get rid of your binding to a specific framework. That's one solution. Another solution I want to talk here about is about micro apps. The idea of micro apps is really simple. The idea of micro apps is that we should not create a big system that can do everything. Because when we are writing those big systems that can do everything, then we have a really hard time when it comes to maintainability. Maintaining such a big system for 10 or 20 years is really difficult. Especially when you have several teams involved, because that means that those teams have to coordinate them other. And this means you're ending up in a lot of meetings. In a lot of meetings with political discussions. Or to put it in another way, you have to talk to them. Okay, nothing about communication, but when you end up with investing more time into meetings than in programming, something goes wrong. Communication within a team is vital, but when you have to do a lot of communications with other teams and when this prevents you from doing your job, then I think we have to find another solution. Another drawback of this big system is that we have just one framework. We cannot change frameworks, we cannot change technologies in the run of the next 10 or 20 years. No one knows what happens in 10 years. No one knows if there is a better framework for the use case we have to implement in 10 years. So it would be nice to have more flexibility here. Another issue is the architecture, because one big system means you can only have one architecture. You have this one-size-fits-all solution, which is also an issue because perhaps some use cases demand another architecture. And at the end of the day, such a big system is hard to change. It is really hard to change. You cannot just change the architecture, the technologies. And in addition to that, when you have several teams involved, those teams are creating contracts. When one team is using source code of the other team, there is a contract. And contracts are hard to change. When you change them, you have a breaking change, which is not good for evolving your system. If you don't trust me, just try to change your renting contract in the next break, or try to change your marriage contract in the next break. It isn't easy at all, you will find out. You have to agree upon new stuff, then you have to find intermediate solutions, and then after some weeks or months, you can transition over to the new status quo. So the idea here is not to go with one big system. The idea here is to split the system up into several tinier parts that can be implemented individually. And in the backend, we are calling those parts microservices nowadays. I think microservices are quite popular in the backend. When you take the same idea and when you put it into the world of front-end frameworks, you're ending up with something like web applications or micro applications, I mean. Some people are calling it micro apps, some people are calling it micro front-ends. This brings a lot of advantages, but also some disadvantages. Let's start with the advantages here. One advantage is you get a separate deployment. That means you don't have blocking tasks. When you are done, just put your bundles and place them on your server, and the user gets automatically the newest version of your part. You don't have to coordinate yourself with other teams. You don't need to find a plan to publish everything together. You can mix and match technologies. Each and every micro application can have its own technology stack, can have its own architecture, a technology and architecture that fits best to your current needs. Another advantage is you need less coordination, and of course you are decreasing the amount of complexity because you don't have this one big monolith, you have several tiny applications that are specialized in one aspect. Of course, everywhere where you find light, you also will find shadow. And this also holds true for this kind of architecture. There are some disadvantages. One disadvantage is you are ending up with a highly distributed system because your micro apps need to talk to each other sometimes. They need to share data, for instance, or they need to inform them about events. Okay, in the web field we are used to distributed systems. I mean, the whole web is distributed, but compared to a traditional monolithic application, this is something new. We have to take care about APIs, we have to take care about resiliency. Perhaps the other system is not accessible all the times, perhaps the other system over there is down sometimes. We are also ending up with distributed data, because we have several systems and each of them can have its own database. And we need to deal with UI composition. For us developers, it is a nice thing to have not one application but 50 tiny self-contained applications instead of it. For us developers, it's great. For the user, it isn't. Because the user isn't interested into bootstrapping 50 applications every morning. This is somehow annoying. And so we need to find a way to present our micro apps as a common big thing to the user. And this is what we need to consider in the front end. Everything else can be solved better in the backend, but when it comes to front-end technologies, we have to find a solution for exactly this drawback. And as it turns out, there are several solutions, and none of them is a perfect solution. And this makes it exciting. This is always the case when it comes to software architecture. We have to find a solution that provides more advantages than disadvantages for our current use case. I'm starting here with the simplest one, with the simplest solution. It's about using hyperlinks. I think hyperlinks are quite a sound technology. They have been there since 2 decades. And I have never ever heard someone say a bad word about hyperlinks, so it really seems to be a valid technology. In this case, you would write several tiny single-page applications and you would combine them by means of hyperlinks. And of course, there are several drawbacks, but hyperlinks seem to be fitting for a special kind of application. I would call it application suites. An application suite like the Google suite, for instance. The Google suite contains several applications, and all of them are self-contained applications, and you can easily switch over by pressing this button here. This button gives you a menu with hyperlinks that are leading you to another single-page application. By the way, the most important aspect of this whole keynote can be seen on this slide. If you forget everything, please always remember this little aspect, namely there is a city called Steierberg in Germany. And I'm really proud of this. I'm really putting a lot of emphasis into that. So please remember this. The city is in Lower Saxonia. Who of you is from Lower Saxonia? Some of you, yeah, I love you people, thank you. You are the best. Okay, let's go on with the boring technical stuff. So when you look at this approach, you have a simple approach, yes, but you will also lose state when you move over to another single page application, and you have to load a whole new application, a whole new page. And this is exactly what we wanted to prevent when we invented single page applications. Another drawback is you have a hard time when it comes to a consistent look and feel. For instance, you have to make sure that your navigation bar or this menu looks the same within all micro apps. And this calls for shared widgets like this here, and this is where the circle closes, because short widgets can be created with web components. If you ask me, web components are a very good fit for this because they work with each and every framework. You can easily reuse them. So in some situations, hyperlinks are a good fit. In other situations, we need something better because we cannot afford to lose client-side state. And in those situations, you will probably go with a shell. A shell that can load several single-page applications on demand. And for implementing a shell, you have several possibilities. I'm starting here with the ugliest possibility. What do you think? What is the ugliest possibility? iframes, yeah. I don't know about you, but I'm getting this strange feeling in the stomach when talking about iframes. No, just kidding. We all know it is not the most popular tech in the world of web development, but it also has some advantages. Some advantages you will not find anywhere else. For instance, an iframe provides the best amount of isolation. Isolation means that the application in the first iframe cannot harm the application in the second iframe. They cannot hack each other, which is important when you have plugins, third-party vendor plugins, and error here cannot influence the functionality on the other side. The same holds true for the layout. Fishy CSS files on the one side cannot influence your layout on the other side. So sometimes it's really a good solution. Another solution here for providing a shell is just bootstrapping several single-page applications. For instance, you would have one index HTML, and there you would bootstrap an Angular application, an React application, and a Vue application, perhaps just on demand by leveraging lazy loading. And when it comes to this, it would be a good idea to wrap those applications, those micro apps, into web components, because web components also give you two advantages here. One advantage is you get an unified API for the shell. That means the shell does not need to know the differences between React and Vue and Angular and all the frameworks that will show up in future. They just need to deal with custom elements, with web components, and as you have seen before, web components behave just like traditional HTML elements. This is one advantage. And another advantage is nesting. As the browser is taking care about rendering web components, you can very easily nest your web components. That means you can use an Angular application and you can bootstrap a component from the React world in the middle of this Angular application. That means you are quite flexible here. That means when it comes to a shell-based architecture and when we decide for web components, we can use them on two layers of our architecture. And in general, I found out it is a good idea to decide between those two layers, because without distinguishing, you're ending up in cycles when doing technology discussions. You have to do one discussions about the macro architecture. This is the architecture that holds together all the single page applications or your micro apps of your system. Somehow this macro architecture is the glue between your micro apps. And then you need another discussion about how to deal with shared widgets. This is what I'm sometimes calling the microarchitecture. How can we package shared widgets so they can be shared amongst our micro apps? That was a lot of theory, I know, but I think that has shown how we can combine those two technologies together to create maintainable systems. And to emphasize this approach a bit, I've prepared an example. This example here is just a shell application, a shell-based application, and it can load other self-contained applications, for instance this one here. I'm calling this my blue Angular client. And this blue Angular client can also use routing. I can route back and forth as you see here. When I'm clicking on the next hyperlink, I'm getting another self-contained application loaded into my shell. That means the shell is always loading the newest version of my applications, and the applications can be deployed individually. They even run in a standalone mode, which makes development easier, which makes also debugging easier, and perhaps we are needed just in this form for some specific use cases. When I'm clicking here on payment, we are seeing my green client. I've forgotten the meaning of this logo, but I think in my point of view, this shows that we can easily mix and match the different technologies here. And when you are looking here, we can easily wrap existing legacy applications using web components, and then we can integrate them into our shell-based system. This here is the macro architecture where it comes to loading self-contained application into a shell. We can also reuse widgets developed by several frameworks. For instance, when I'm clicking here, we are seeing that I'm reusing a widget from the Vue world and a widget I've created with Vanilla.js. And when I'm clicking here, we are seeing I'm reusing a widget from my blue client. Okay. Great. So far you have seen several solutions to create a maintainable, sustainable architecture. And of course, now you are wondering which solution fits best for your needs. And this is very difficult to say, because when we are honest, every one of us wants to have all the advantages, and no one of us wants to have any of those disadvantages. So this is quite difficult, and that's why you will probably end up in discussion cycles when discussing about those approaches. And that's why, after a lot of discussions with my customers, I came up with a decision tree. A decision tree that can help you to identify a first architectural candidate. Of course, this decision tree is not the last word on this, but it proved to be handy for finding a first architectural candidate. The first question I would ask you using this decision tree is, do you have shared state? And do you have a lot of navigation between your applications? When you think about the Google Suite, you don't move between the Google applications back and forth all the time. And when you say, no, this isn't the case here, then chances are high that you don't need one big single page applications. So chances are high that you just have several single page applications, and those applications can be connected to each other by the means of hyperlinks. When you say, oh yes, There is a lot of traffic going on. The user is moving back and forth, and we have a lot of shared state. Then the next question is, do you have to integrate legacy applications? Do you have to integrate existing PHP or Java or ASP.NET applications? And do you need a very, 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 very strong isolation? Because, for instance, you have several vendors shipping some products that are integrated in your suite. When this is the case, then consider iframes. Of course, iframes are not a good fit for public websites, but in this specific case, they are a good fit for applications that are hidden behind a login screen. Of course, you will not win an architectural award with it, but when it comes to software architecture, it's all about trade-offs. It's about finding the right trade-off for your specific solution. When you say, no, I don't need this, then the next question is, do you even need a separate deployment? Do you even need to mix and match technologies? And when you say, oh yes, we need this, because we have several UI teams or several teams in general, and those teams need to work independently. They should have their own solutions. They should need to talk to each other all the day. And when you say, yeah, we need to mix technologies because of long time evolution, then try web components. Try to go with bootstrapping several frameworks and wrap them, as seen before, into web components to provide a unique interface to the shell and to provide the possibility of nesting. And if you say, no, that's not important here, then go with a monolith. Then go with just one well-structured single-page application, as it is quite traditional in this area. Sometimes a monolith is the right solution. I know some people are using the word monolith as a curse. They are saying, hey, you are using a monolith, you are a bad guy. No, that is not true at all. Sometimes it is fitting. But when going with a big monolith, you have to take care about your structure, about your architecture. You have to prevent that each and every part of your application is talking with each and every other part. Because when all the parts are wired up together, then they are very hard to change and very hard to exchange. So let me come to a conclusion. We have seen that web components are for decoupling from your framework. You can use your web component for within each and every framework. And we have also seen that micro apps helps with decoupling, namely with decoupling between teams and projects. Teams and projects can be individually, they can be self-contained. And that's why I think it's a good idea to combine those approaches, combine web components and micro apps, and I promise you, wonderful things will happen. And in addition to that, it also allows you to use the best technology for your current use cases. That's from me. So thanks for coming. Here you have my contact data. You will find all my slides in my blog. So have a nice day and enjoy the conference.